This conference will now be recorded.
Hello, is it audible, everybody?
Yes, sir.
Okay. Let everybody arrive. Okay, some of your friends are still joining, so let them join. Then we will start.
No, sir.
Okay.
কলেজ খুলে গেছে অত অনেক পিক ডিলিট হয়ে গেছে কোনো আর
mute, please mute. Okay, chalo. So most of our students have joined, our friends have joined. Okay, so let's start. Uh, good morning. Good morning, everybody. Hello. Good morning, everybody. Now, before starting, yeah, good morning. Good morning, Darshan. Before starting, I would just like to ask जो जो हम लोगों ने लास्ट क्लास में किया है, ठीक है, उसमें कोई किसी को कोई किसी भी प्रकार का कोई दिक्कत है, कोई प्रॉब्लम? आई रिमेम्बर रोहित पॉल ने बोला था मुझे दैट सर हाउ टू डू इट विथ मल्टीपल वेरिएबल
Yes,
लीनियर,
sir.
हाँ, linear regression using multivariable, huh? So that I will show today, Rohit, don't worry. Okay, apart from that, any more queries, any more question? Okay, so right now कोई
Sir,
query नहीं है.
how to
हाँ,
check accuracy for different types of models?
हाँ, how to find accuracy na? See, this was
Yes, sir.
a regression, yeah, Oniket, see, this was actually a regression model. Okay, that's why we found out the error. Okay, now when we went for k nearest neighbor, I hope so you saw how do we found out the accuracy, right? Okay, today
Yes,
I
sir.
will show you some more classification algorithm, that is decision tree and random forest. Decision tree and random forest. In that part, when I will show you, I will consider your question and I will show you how to find out the accuracy. Okay,
Okay, sir.
no problem. चलो चलो.
Okay. Yes, sir.
ओके ओके, चलो. सो हम लोग थोड़ा यहाँ पर स्टार्ट करते हैं, जुपिटर नोटबुक स्टार्ट कर लेते हैं. आफ्टर स्टार्टिंग जुपिटर नोटबुक, वेट, वेट, आई एम शोइंग यू वन डेटा सेट. डेटा सेट, वेट, this. See, okay, this as you can see the data set on your screen. The first one is serial number, not required. It is not a very big data set. It is a very small data set. Around 150 records are there, and this data set I will send it to you. Okay, so this is not a downloaded data set. Okay, this data set is actually collected by one of my student. Okay, he was actually doing IoT and all. So he actually collected using blood pressure monitoring sensor, the piezoelectric monitoring sensor. Getting the point? He used that blood pressure monitoring sensor. He bought it, and with the help of that, he actually collected. Actually, this is done on around 10 to 12 people. Okay, so multiple time he approached the people at multiple time. Okay, multiple times he approached up single people, not at the same time, in various day, and he collected around 150 records. Means if there are 10 people, that means at a single people he has approached 5 times, right? So it took few days for him to collect this data set. Okay, around 1 week he took to collect the data set, and this is actually a real-time data set. This is not a downloaded data set. Okay, I promise you, you will not get it anywhere on the internet. कहीं भी आपको इंटरनेट पे ये नहीं मिलेगा, ठीक है, कहीं भी आपको ये नहीं मिलेगा. समझ पा रहे हैं? तो आपको क्या करना है, आपको सिंपली ये डेटा सेट को देखिएगा. इसमें क्या है, सीरियल नंबर कलेक्शन था, ठीक है, और जो डेटा कलेक्ट हो रहा था सेंसर से, वो डायरेक्टली कहां सेव हो रहा था, इनसाइड दिस XCSV फाइल. ओके, द डेटा वाज डायरेक्टली गेटिंग सेव्ड इनसाइड द CSV फाइल. ओके, now this is actually the pulse. This is actually the pulse rate. Here the systolic pressure and the diastolic. Systolic and the diastolic, blood pressure, it's something like this, na, 120 by 80, that is normal, na. So 120 by 80, so suppose the systolic was 128 for person number 1, and his blood pressure was 73, and the diastolic pressure is 78, something like that. Okay, so is this a classification problem or regression problem? First of all, tell me. How do we classify this particular problem, whether it's a classification or regression?
So here what we need to predict that has been not been given, so it is unsupervised learning too.
No, Darshan. It's not unsupervised, Darshan. I'm telling you. See, here actually the thing is that we are actually giving the input. What we are giving the input? I have to give the input, that is the pulse. Okay, I have to give the input, the pulse. And here this is multivariable, na? So here I have to predict the systolic and the diastolic.
Okay, means we are predicting two outputs using one feature.
Yes. So pulse will be given the input, and the systolic and the diastolic will be taken as the output.
Okay, sir.
So this is a very interesting real-time data. This is a very interesting real-time data. Okay, and see, I have already mentioned the code because it is not that much, because we have done the same thing previous day also. So as you can see over here, okay, as you can see over here on the screen, that first of all I have here read the data set. Okay, I have read the data set over here, serial number, pulse, systolic, diastolic. Okay, after reading the data, I have did some analysis to check whether any null value is there or not. Definitely there is no null value, since it's a real-time collected data. So we have means efficiently managed this. Okay, I was also present there. Okay, so we have efficiently managed this, and drop if there is any NaN value, not a number value. If, then we will actually drop it if present, basically. So this is basically the concept. This is actually the info of the data set. All not null, int 64 columns. Okay, integer 64, total 4 columns of data type int. Okay, ranging from 0 till 149 in a data frame. Description of the data set is something like this. Description of the data set. This is actually the description of the data set, and the most important and valuable part. Okay, and just below that I have actually dropped that serial number, because this serial number is useless column, na? We don't require this. So it is actually increasing our dimension. So we don't need this, basically. We don't need this. Okay, so just have a look. I have dropped the serial number. So ultimately what we have the pulse, systolic pressure and diastolic pressure. Pulse, systolic pressure and diastolic pressure we have. That's it, done, no problem. This is the enough. no problem. Okay, now on the x-axis, df.ilog, I have taken all the row. Okay, and I have taken this is, I have taken the pulse. See, pulse means 0:1 means the 1th. Okay, sorry, the 0th column on x, 0th. Okay, the 0th. And on the y, see, systolic is taken, systolic. Okay, means all the rows and the last column. देखो -1 मतलब the last column. And on z, all the rows and -2, that means the diastolic, means the second column, something like that. Just have a look. Try to understand this concept. See, I have just printed z so that you can see the things very well, or you can understand the things very well. See, multiple variables are there now, so I just did this thing. So you just try to understand. Okay, and if you face any problem, you just tell me. Any problem?
Sir, can you repeat?
Yeah, see, Resmi, just have a look. On the x-axis, I have taken this pulse column, okay? This pulse column, okay? That's why I have written over here in the column.
Hello, sir.
Yes.
Hello, sir. বলছি আমার মানে আমার কতগুলো বন্ধু বলছে যে ওর নাকি আনমিউট হচ্ছে না।
আনমিউট হচ্ছে না?
না।
আচ্ছা, ফ্রেন্ডের নাম বলো।
স্যার পঙ্কজ ঘোষ।
পঙ্কজ ঘোষ। না, পঙ্কজ ঘোষের তো মাইক এখানে শো করছে যে মানে ওর তো মাইকই খারাপ আছে। ওর ইট ইজ শোয়িং সি পঙ্কজ ঘোষ মাইক নট কানেক্টেড। ইটস শোয়িং মাইক নট কানেক্টেড। হ্যাঁ, পঙ্কজ ঘোষকে বলো ওকে লিভ করে যেতে বলো। টেল হিম টু লিভ এন্ড রিজয়েন अगेन। হিজ প্রবলেম উইল বি সলভড।
স্যার বলছে নাকি ও তো লিভ করছে আবার রিজয়েন করছে, অনেকবারই করেছে বলছে।
No, Pankaj Ghosh, see, I'm saying, wait, I'm giving the screenshot in the group. Pankaj Ghosh, na, wait. Just a second. Pankaj Ghosh. That's it. Okay, see, can you see? His mic is off. Off আছে ওর mic. হবে না?
Okay.
হ্যাঁ, আমি বাকিদের দেখিয়ে দিচ্ছি। Just have a look. I'm showing you about rest also. Rest का बाकी सबका mic देखो। अब वही पंकज घोष का mic देखो, दिखाते हैं आपको। ये देखिए, सबका माइक देखिए, और पंकज घोष का माइक देखिए।
हाँ सर।
सो इट इज हिज प्रॉब्लम टुवर्ड्स उनका कोई नेटवर्क इशू है, उनको नेटवर्क इशू আছে, ওকে বলো আবার থেকে রিজয়েন করতে। ওকে
ওকে স্যার।
Yeah, see, Akash, the class is actually 10:30 to 1 p.m. Getting the point, Akash? Yeah. हाँ, तो एग्जैक्टली इसमें अटेंडेंस भी है और 5 मिनट्स का, हाँ, और 5 मिनट्स का ब्रेक भी है इसमें, 5 to 7 मिनट्स का, ठीक है? नहीं तो एग्जॉस्टेड हो जाइएगा ना, यू विल गेट एग्जॉस्टेड। Okay, that's why I give a break now. So yeah, so on the x-axis I have taken the pulse, on the y-axis I have taken the systolic, and on the z-axis I have taken the diastolic, right? I printed z to see whether diastolic is getting printed or not. So 128, 127, 129, see, diastolic. Oh, sorry, systolic is getting present or not. This is not diastolic, wait, -2. This is actually systolic. This one is systolic, and this is actually diastolic. this dashed. Okay, this is dashed. Now, so printed systolic, see 127, 127, the same value. Okay, so x, y, z is represented something like this. Now, linear regression, simple linear regression. I have trained the value, or I've trained the model. I've trained the model using the data set, okay, where actually the test size is actually 0.2. That means 20% on the test and what to say, 80% on the training part. 80% on the training. Created the model, fit the model, that means train the model, and after training the model, the graph is something like this. X-axis PLT dot scatter. This is actually the training data. Training. So scatter plot is actually the training data. Whatever you are getting by scatter, na? Scatter. Just a second. Let the data set get read. Okay, see, now it's visible, perfectly visible. It's perfectly visible now. So the scatter plot, it is actually the training data, and the regression line is actually the prediction on the training. Prediction on the training. Okay. So this is actually titled linear regression on pulse and diastolic on training data set. See, this is actually the graph. This is actually the graph. Have a look at the code and then tell me. If you face any kind of problem, just tell me.
So this BLT dot figure fixed size, this means 10:10, 10 means 10 rows and 10 columns, right?
Exactly. You can alter this according to your size. See, I am doing here, suppose 5 rows and 7 columns, huh? 7 columns. Just have a look at the graph. It's consuming much time. Usually it doesn't consume basically. I think there is a problem. No problem. If there is a such types of issue, then we can do one thing. I just need to stop this kernel. Okay, again I need to start this with this particular button, right? And I will restart this. And again, go to the cell, run all. That's it. Something like this. See, I'm getting something like this.
Yes, I got it.
Okay, so it's totally dependent upon you. Again, same problem. Okay, let this come and after that let it work and just have a look at this particular figure here. A linear regression, the same thing has been given on the test data. Okay, this is actually the training data, this is actually the test data. I think this is also going to hang. No problem. Achha, I came to know basically why it's not showing the answer. The reason is that here I have to give the input basically. This here I have to give the input. Getting the point? Here I have to give the input. That's why it's not working. Anyway, see here if I give here suppose 73 na, and if I hit enter, so it's working, right? And if I run this, see now it's okay. What happened? scatter, and this is actually the plot. Okay. Okay, so this is basically the thing. Now, just have a look. Okay, if this code is clear, have a look at this particular code. Wait just a second. Okay, so this was actually the training. This is actually the training part. Now, and this is actually the testing part. The same thing, testing part, same code. Here we have written what? For the scatter we have written the training. For in the testing part, for the scatter you will write the test. Okay, and here we have written on the x-axis train and on the y-axis the prediction of the train. And similarly here on the x-axis test and on the y-axis prediction of the test. That's it. This is actually the prediction line. This is actually the prediction line. Okay, that's it. Clear? Now let's move ahead. So y1 df.ilog. Okay, so all the rows and 1 and 2th means the systolic and diastolic on x. See, systolic and diastolic on x. Just have a look. Systolic and diastolic on x.
হ্যালো স্যার,
Okay,
শোনা যাচ্ছে
yes.
আমার আওয়াজ?
হ্যাঁ শোনা যাচ্ছে, পঙ্কজ বল।
হ্যাঁ হ্যাঁ, ওই তো আমার আসছিল না, আওয়াজ আসছিল না ওর জন্য।
কোনো অসুবিধা নেই পঙ্কজ, এখন ঠিক আছে, এখন ঠিক আছে, নো প্রবলেম নো প্রবলেম। ঠিক আছে, কন্টিনিউ করো, ঠিক আছে, কোনো অসুবিধা হলে আমাকে জানাবে। Right, so just have a look. This is actually the systolic pressure and the diastolic pressure. On the y-axis we have the systolic and the diastolic, and on the x we are going to have what? We have taken only the -2. This is actually pulse, right? Pulse. See, this is how I have divided the data set. No problem, have a look. If you face any kind of issue, just tell me. Okay, the features I have taken on y, and actually the the target is actually on the y and the feature is actually on the x. Now same code divided, again splitted the data. After splitting the data into the training and the testing part, that is into the 80% and 20%, and creating the model, training the model, and after prediction I'm getting something like this. I'm getting some result. So how many results I'm getting? Basically, see, it's 150 records, no? So what is 20% of 150? It's 30. So total I'm getting 30 in array format. 30 results in array format. Okay, 30 results in array format I have taken this. See, we are training the model.
So one question.
Yes, please.
Sir, in the verb you have done the prediction. So what was that prediction and why this means 2 basically you have done?
Yes, here see here I have actually done the prediction, na? Okay, here actually I have done the prediction. Here I have taken, just have a look, here I have taken on x I have taken the pulse, on y I have taken the diastolic, on z I have taken the systolic. Okay, here I have passed x and y, here I have passed x and y. Means if we consider pulse as the input, it is giving me diastolic as the output, right?
Yes, sir.
Okay, and here just try to understand the concept. Here I have taken this particular X as the input, means the feature, and Y as the target, right? So if X1, this X1, that means if pulse is the input, then Y1 is going to be the output. So what is Y1? Y1 is actually systolic pressure and diastolic pressure. Now you understood what is the prediction over here?
No, sir. What is the need of the above code then? Why we are
No,
taking only pulse and diastolic? Because we can do directly this one, pulse, systolic, and diastolic, because we have to predict both.
yeah, you can directly do this. You can directly do this. You can directly do this. If you directly do this, your code will grow very shorter. Your code will grow very shorter, right? And you can directly get the output also. And in few minutes, your work will be completed. I agree with you. I agree with you. But you know, have you gone through some research papers? Any of the research paper? Okay. Have you seen? They have always tried to compare their output or their algorithm with the pre-existing. Have you seen that?
No, sir. I've not seen.
No, because yeah, see, when you will go for your PhD, na, in our work, you know, whenever we show the work, na, see, whenever my paper will get published, I will show it to you. Okay, we have to compare this with a lot of other existing algorithms. Means how our work is better than the previous work. Otherwise, we could have given directly our own formula. We could have given directly our own idea. Yes, this is our model and it is predicting well, and that's it, done. But that is not a quality work. That is not a quality work. Getting Darshan? You have to show the existing method, then you have to show your own method, and then you have to give the comparison. The more comparison you will give, the more weight you will get. The more weight that particular paper will get.
Okay,
Getting
sir.
the point? So this is basically R&D field. Is yes or no? So that's why
Yes,
I
sir.
have showed this comparison. If you said that, sir, if I remove this, won't I get my output? Why you will not get your output? 100, not 100%, 200% you will get the output. If you do say that, sir, it's no need of using that. Yes, there is no need of that. But for the comparison purpose, I showed this part. Getting the point, Darshan?
Okay, sir.
Yeah. Otherwise, you could directly reach here and you can directly start with this code. Directly start with this code. Here we are training the model, and here I'm giving the prediction, right? So after giving the prediction, so here is actually the input part. Here I have taken the input part. See, this is actually the input. N equal to int input, something like this, input part. So this is basically what? 73. So go to the actual data set. Actual data set is this data set. So if I give the pulse as 73, my systolic pressure should be 128 and diastolic should be 78. Obviously we will not get 100% accurate, but we will get a nearest number, right? If my pulse is 73 is the input, my diastolic should be, sometimes it should be 128 or near to 78. Okay, so see, if I have given the 73 as my input, they are giving my model is giving me the something like 124 as the systolic and 75 as diastolic. But what is the actual output? 128 and 78. So it is perfect now. It is okay, no problem. My model is giving a very nice prediction. See, it is giving very nice prediction. The actual output should be 124 and 75. Actual output is 128 and 78, but it is giving 124 and 75 or near to 76. 76. What is the problem? Isn't the model predicting good?
Yes, sir.
Isn't it? Now you might be wondering that if I give sir 71, okay, if I give 71 or if I give sir 76, suppose 76, then the output should be 129 and 75. If I give 76, let's see. If I give the pulse input 76. 76. So my model is giving the prediction what? My model is giving the prediction. Actual value is 129 and 75. Actual value is 129 and 75. My model is giving the prediction 125, near to 125 and 77. See, it's well and good. And you can see I have found out the mean squared error. It's around 4.61. Perfect. Not bad. Not bad.
Sir, if we add this mean squared error with our result, then sir, it will show the perfect result when we display our result.
You are saying with pred, na?
Yes, sir. If we add Pareto plus RMSE, then it will show the perfect result.
Yes, so that is the formula, na? Like 70. Wait, that is the formula. Wait, I am giving 68 now. Okay, it will be pred one itself.
It will be Pareto 1 only.
Pred
Yeah,
one
it will
only.
be Pareto 1.
Yeah. For 68, what it is giving? It is giving 124 and 74, right? And 68, what it is? It is 125 and 69. It's giving very nice. Because again, you see bottom there is again 125 and 72. So 69 and 72 average will be near about something like that, 72 or 71 itself. And Rohit Paul, you are actually giving the formula, okay? And you are absolutely correct. You are absolutely correct. So that is actually the formula.
Okay, sir.
Okay, you are absolutely correct. You moved in the other direction, but you are absolutely correct. I agree with you. So this was actually using this multiple variable. Now tell me, any doubt with this particular
Sir,
code? Yes, sir.
So why we need to, means as Rohit told that it is a formula that we need to add root mean square error with the accuracy which we got, with the predicted which we got. But sir, we can see that if we add the root mean square error 123 with 123 with separate, I'm adding just like normally it is showing like it is giving 127 and 78. So it is increasing our value too. So why need to add? Now we can see directly that it is
No.
showing
Yeah,
the
yeah.
prediction.
It is showing the Darshan, you are right. You are also right. See, Rohit actually tried to say that, sir, if we basically try to add, then we will get our near actual value. He said, not the perfect thing. Because we know that I told you that actually what is mean squared error? Mean squared error is actually it is the simplest, or we can say it is the most common loss function, right? It is the most common loss function. Means we basically take the difference between our model prediction and the ground truth. Okay, then we square it. Okay, then we square it, and then we average it across the whole data set. This is the actual formula.
Yeah.
Getting the point, Darshan?
Yes, sir.
Getting the point. I am telling you basically what is, you may write down. Okay, to calculate the mean squared error, we basically take what? We actually take the difference between model prediction and ground truth. Wait. Model prediction and ground truth. Okay, this is the first step, right? This is the first
Ground
step.
truth
Model
means ground truth
ground
means
truth is the actual truth, the actual value.
actual value.
True positive, true positive.
Truth value.
True positive. Okay, the ground truth. Then we do what? We square it. Then we square it. Then average it. Then we average it. Then we square it. Then we average it. Okay, and we average it across the whole data.
Whole data set.
Okay, yeah, we average it full data set. Right. So this is the truth now. This is actually the formula. So that is what actually Rohit was trying to say, that we will get near about that, isn't it, Rohit?
Yes, sir. Yes, sir.
Got it, Darshan? Clear to you?
Yes, sir.
Okay. So mean squared error basically tells us how close our regression line is to the actual data point. Okay, how? Because it actually takes the distance from the point to the regression line, and these distances are called error, and these errors are basically squared. Okay, why? Because if we square this error, it will remove unnecessary negative signs, right? And then we try to minimize this point, or we say mean squared error. Why? Because the moment we minimize, the more we minimize or lower the mean squared error, the better is the forecasting. The better is the forecasting. Getting the point? Okay. Now there might one more question arise in your mind that, sir, what is a good mean squared error? Sir, what is a good mean squared error? Means what value should be good? What value should be accurate? See, I will tell you one thing. There is no correct answer to this. There is no correct answer to this. Means there is no correct value for mean squared error. Remember that. Means if we simply put the lower the value, the better is the forecasting. Okay, and if the value is 0, that means the model is perfect, means highly perfect. Getting the point? Yes or no? If the value is 0, means the model is highly perfect. So there is no correct answer. There is no correct answer. Okay, so the MSE basic value is actually selecting one prediction model over the other. Getting the point? One prediction value over the other. If you want to compare this, you can here you have used linear regression. You might use some other what to say algorithm. Okay, sometimes suppose random forest regression you can use. So suppose that is giving your low error. Suppose it is giving 2.61. Then that is highly perfect than linear regression. Okay, so there is no such value which will define actually, yes, this is the best mean squared error. We always try to minimize this loss function. Always try to minimize this loss function. Okay, so this example I have completed, and if you want or if you have any doubt, okay, you can ask me before I start my what to say next session. If you face any problem, just tell me.
Sir, here our input is 1 and output is 2.
Yes.
Two values we are predicting, and if the input is 2 and the output is 1, then
Exactly.
will it be
Yeah, very good.
multivariate?
Yes, multivariate. Multivariate.
Okay, sir.
Multivariate. That I leave on you. If you can do that problem, that means definitely you are trying to make machine learning as your career. I will show again. I will show. Getting the point? I will show you.
Yes, sir. Yes, sir.
Okay, I will show you that part. But if I give you a task type, okay, will you be able to do it? It's going to be very interesting.
Sir, like as Rohit told that multivariate, like 2 inputs, 1 output, or multiple inputs, multiple features, and 1 target. So for that type of data sets, or for that type of model, linear regression model, if we calculate linear regression, what is the gradient loss for function gradient loss for that? If you want to calculate the gradient loss,
Means yeah, you are asking me means what will be actually the
formula,
calculate the
gradient loss.
yeah
Gradient
loss.
formula.
Okay, you do one thing. In the tomorrow we will discuss about this, or if possible we can discuss about this in the second half, right?
Okay, sir.
Okay, I just want you to do one thing. I just need you to do one thing. Just give me till prediction. Anybody, any one of your friend, just give me a code till prediction. Okay, that gradient loss function, okay, or how to minimize the cost function, okay, that I will show you. Agree?
Okay,
only till prediction you have to give, means you have to divide the data set into training, testing, and you have to give the prediction. That's it. And compare the prediction in a data frame. Okay, then that part, that will be the most interesting part that we will do in our class.
Okay, sir. So then we will take the data set from the Kaggle only. Some small data set.
Any data set, you can take the data set from Kaggle, Darshan. You can prepare your own data set. You can prepare your own data set. Okay, or if you want, I am giving this BDP data set, this blood pressure monitoring data set, I am giving it to you. You can work in this data set only, no problem.
Okay, sir. Here only, sir, I will give pulse and diastolic as an input, and I will calculate systolic.
Yes, yes. Okay, or you better do one thing. Better do one thing. Take systolic and diastolic as the input and try to predict the
And
pulse.
calculate pulse. Yes, sir. We can, because that is will be that will be better.
It will be the most interesting task that we will do today. Most interesting task, I promise you. Okay, then this session will actually grow. This session will become so much interesting. Okay, so I will show basically. So there are lots of things to learn in machine learning, you know, lots of things are there to learn. Okay, so this was till here. Any doubt? Any doubt? Do anybody has any doubt? If you have any doubt, then I will try to clear it. No problem. Shall I proceed to the next part? Okay, okay. Darshan is saying yes, sir. So let's move ahead. Now, wait. I will show you what to say. The decision tree and random forest. But before that, you know, I will do one thing. I have tried to since I have done this linear regression now. Okay, I've showed you linear regression. I will show you right now logistic regression. Logistic regression. Okay, so that will go hand in hand. Logistic regression, a classification algorithm, logistic regression. It is basically a classification algorithm. Okay, it's a classification algorithm. Getting the point? Logistic regression. It's a classification algorithm. Right. Now, let me share the PPT. Let me share the PPT first. Just a second. Okay, is it visible? Is the PPT visible?
Yes, sir.
Okay.
Sir.
Yeah. Let me click on this slideshow from current slide. Okay. So that's the thing. Logistic regression, it's a classification algorithm. Logistic regression. The name is logistic regression, but it's basically a classification algorithm. Okay. Now, classification, whether the email is a spam or not spam, whether the online transaction is a genuine transaction, it's a fraud transaction, or whether a cancer is a malignant cancer or benign cancer. Okay, or tumor, whatever, same thing. Right. So if the output is basically a discrete one, basically it is in the form of yes and no, 0 and 1 only, then logistic regression is basically used. 0, 1, yes, no, spam, not spam. Means if the decision is between two, then logistic regression is basically used. Getting the point? Now, why is actually the predictor? It's the output. Why is the prediction? It is the output, so it belongs to either 0 and 1. 0 is suppose a negative class, example benign tumor, or 1 is a positive class, example malignant tumor. Okay, now just try to have a look. As you can see, the value of yes is basically 1. Okay, value of yes is basically 1, and the value of no is basically 0. And can you see x-axis represents the tumor size and y-axis represents whether the tumor is actually a malignant tumor or benign tumor, right? So here there is one threshold. What is that threshold? The threshold is actually 0.5. 0.5. Threshold is 0.5. This is the margin basically. So if a person, or if the value reaches above 0.5, if the value reaches above 0.5, then the tumor is actually a malignant one, and if the value is below 0.5, then the tumor is actually benign one, right? Getting the point? Now as we can see that the value of a logistic regression lies between 0 and 1 inclusive. 0 and 1 inclusive. Okay, 0 and 1 inclusive, right? So what type of curve we will get? What type of curve we are going to get? See here, I have said that threshold classifier output is actually 0.5. Means if our hypothesis or if our model prediction is basically greater than equal to 0.5, then the prediction is actually y1, means the the tumor is malignant one. And if the function is actually less than 0.5, then the prediction is y is actually 0. It's actually 0. Getting the point? It actually 0 means the tumor or the cancer is basically it's benign cancer. It's benign cancer, right? So we can see that the value of logistic regression is basically lies between 0 and 1 inclusive. So we will get a sigmoid curve. We will get a sigmoid. We'll get a sigmoid. See, classification, it can be either 0 or 1. Means it can be either 0, means whatever it will be, it cannot go below, it cannot go, see, logistic regression, it cannot go below 0 and neither it can go above 1. But other classification algorithm like suppose any other, or suppose if you consider the linear regression, the value of linear regression, can it be greater than 1? Yes or no? Can the value of linear regression, can it be more than 1?
Yes, sir.
Yes. Can it be less than 0?
Yes, sir.
Yes, it can be less than 0. But here in case of logistic regression, can the value of logistic regression be less than 0? No. Can it be greater than 1? No. Okay, it will always be between 0 and 1 inclusive. So this is actually the difference between the logistic regression and other classification, or we can say if you compare linear regression, then linear regression and logistic regression comparison. Getting the point? Now, okay, logistic regression hypothesis representation. The hypothesis representation would be something like this. The hypothesis representation will be basically, it will be greater than equal to 0 and it will be less than equal to 1. So always we are going to get a sigmoid function for logistic regression. S curve, we will always get a S curve, sigmoid curve. See, just have it. Try to understand this concept. This is a very, very interesting example. 0.7 is actually the margin, margin, or we can say the threshold, we said, threshold. Any problem? Now, possibility that y equal to 1 given parameterized by theta. Now, as we can see over here, the formula, I will show you basically the representation. I will click here, paint. Okay. Now, Got it? Now, this is threshold 0.5. If my model predicts 0.5 or more than 0.5, then it is cat. And if it is 0.5, then dog. Okay, then dog. So for this type of algorithm, we basically get a sigmoid curve. Sigmoid. 0, 1. Am I right? In linear regression, it would be something like this. The value can be greater than 1 also, the value can be less than 0 also. Okay, that's what is actually directed inside this particular PPT. Now, logistic regression decision boundary, which is basically called threshold. See, this is actually the decision boundary, GZ. Okay, so GZ, if it is greater than equal to 1, see, this is actually the hypothesis function. Since we are getting a sigmoid, so this is actually the function GZ. So here h theta x equal to g of theta tx. So GZ value will be something like this, 1 upon 1 plus e to the power minus z. So this is actually the formula for that sigmoid curve. For the straight line, what was the formula? H theta x equal to theta 0 plus theta 1 x. Remember, for linear regression, h of theta x equal to theta 0 plus theta 1 x, something like that, right? It was the formula. So here, yes, the formula for the sigmoid is basically 1 upon 1 plus e to the power minus z. 1 upon 1 plus e to the power minus z. Okay, where suppose the predicted value y is equal to 1 if h theta of x is greater than equal to 0, and the y prediction is basically 0 if h theta of x is less than 0.5. It's less than 0.5. Clear?
Yes.
Yeah. Try to understand this. There are two classes. Oh. There are two classes. One is this a red cross class, and the other one is this blue circle class. So if this is actually the formula, h theta of x equal to g of theta 0 plus theta 1 x1 plus theta 2 x2 plus theta 3 x3 till theta x xn, theta n xn, right? So here predict y equal to 1 if minus 3 plus x1 plus x2 if it is greater than equal to 0, right? So this is how basically we fit or find the parameter theta. Getting the point? Hello everybody, are you understanding? This is very simple mathematics.
Yes, sir.
Okay. Now, here I have done a lot of here, so not required. This one is not required. Look at this logistic regression cost function. Here also we will get some error. Here we will also get some error, and that is actually called cost function. So how to minimize this? Something like this. Here the most important thing is that if this is actually the formula for logistic or regression or for the sigmoid curve, h theta of x equal to 1 upon 1 plus e to the power minus theta x, something like this. Okay, so here how to choose the parameter theta? How to choose this parameter theta? How to choose the parameter theta? How to choose? This is a very important question. See, cost function of linear regression. Okay, if we consider this j theta equal to 1 upon m I equal to 1 till n half of h theta x of I minus y theta y x of I. So this is actually the cost. Remember the cost function of linear regression that we did previous day? The cost function for linear regression that we solved using gradient descent. Okay, so similarly, yeah, this was actually the cost function, right? Now This was actually for non-convex and this is actually for convex. Now cost function for see the cost for linear logistic regression. The cost of h theta x comma y, here it is something like this, minus log h theta of x if the value predicted is 1, or if the prediction is 1, and if the prediction is 0, then minus log 1 minus h theta of x. See, this is actually the cost function. This is actually the cost function. See, I think it is much more easier than linear regression, isn't it? Here the prediction will be 2, na? Either it will be 0 or 1 format. So there will be two functions, na? Two functions, two hypotheses will be there. Okay, now cost equal to 0 if y equal to 1. Okay, h theta of x equal to 1. But as h theta of x tends to 0, so cost approaches infinity. Right? So we will penalize learning algorithm by a very large cost. By a very large cost. Otherwise, it will reach infinity. So we are going to penalize it with a very large cost. Right? Now, see. In logistic regression, the cost of our hypothesis prediction function in our training example is something like this. Y belongs to 0, 1. Where the cost is something like this. If y is 1, then the cost will be something like this. And if y is 0, then minus log 1 minus h theta of x. Okay, h theta of x. Then you tell me, here is one suggestion for you. Which of the following are true? Which of the following are true? I have already done it, but still, which of the following are true? Is number 1 true? I have already given the answer. Is number 1 true? If h theta of x equal to y, then cost of h theta x comma y equal to 0 for y equal to 0 and y equal to 1. Yes, the first one is true.
Yes, sir. 0.
The first one is, yes, the first one is true. Because the cost function is equal to 0. Okay, the cost function is equal to 0. Okay, why? Because the h theta of x is equal to the y, means the predicted value. Okay, then definitely the cost is going to be 0 ना. The cost is the minimum. कोई एरर ही तो नहीं है. जो हमारा x है वही तो हमारा y है. h theta of x हमारा जो फंक्शन जो प्रेडिक्शन है दैट इज इक्वल टू द y, तो दोनों तो सेम हो गया, राइट? तो हमारा कॉस्ट में यहाँ पर 0 होगा, right? And if y is equal to 0, then this cost approaches infinity. This is also true, just now we studied, right? And if y is 0, then cost h theta x comma y tends to infinity as h theta x approaches 0. No, this is not true, right? And the last one is also true. Regardless of whether y equal to 0 or 1, if h theta x equal to 0.5, then the cost of h theta x comma y will always be greater than 0. That is always true. That is always true, because we have I think the last one is we studied in the first line itself. The last one we studied in the first line itself, right? This is a very interesting topic. So if you face any problem, any kind of problem, you just tell me, huh? Please, I will sort it out. Yeah, see, if your mathematics is okay ना, तो कोई doubt होगा ही नहीं, no doubt. If your maths is okay, then no problem with this, right? So this was actually our A simple example, basically. A simple example that we saw. Okay, now the next. Logistic regression, simplified cost function, and gradient descent. Logistic regression cost function. This is the logistic regression cost function. The second one. The first one was actually for the linear regression, and the second one is actually basically what it is for the logistic regression. Note y is 0 or 1 always. Always y is 0 or y is 1. Okay. So if we find out, so cost of h theta x comma y equal to minus y log h theta x. Okay. And if the cost is basically 1 for 1, it is actually minus of 1 minus y log 1 minus h theta x. So if y equal to 1, then cost is something going to be like this, and if y is equal to 0, then the cost is something like going to lie like this, isn't it? The first see cost h theta x comma y equal to minus y, okay, log h theta x. This is actually for what? For y equal to 0. And for similarly, the next one is actually what? It is for y equal to 1. Right? We know all these things. We know these things because it is already, see, it is already in the second line only. You see, after j theta, cost h theta x comma y equal to 2 formulas are given, for y equal to 1 and for y equal to 0. For y equal to 0, right? 2 formulas are basically given. Right? Now logistic regression cost function. Now, if both are taken together, see, both are taken together, our formula might something look like this. Just have a look. M is actually the number of data points. I actually start from 1 till M, the number of data points. So if taken together, both the formulas are if taken together, it would something look like this. Now your task is to get the theta. Okay, to fit parameter theta. To make a prediction given new variable, so the output h theta x would be something like 1 upon 1 plus e to the power minus theta t x. Because this is actually the formula for the sigmoid one, and that sigmoid is actually the prediction. Here in linear regression, straight line was the predictor line, and here the sigmoid is actually the prediction, right? Sigmoid. So the formula for that sigmoid is actually what? 1 upon 1 plus e to the power minus theta tx. Why? Because logistic regression value basically lies between 0 and 1 inclusive. So here we will not get a straight line. Here we will get sigmoid. Okay. Now gradient descent applied to it. Partial derivative, again partial derivative. Gradient descent applied, partial derivative. And this is actually, since we know it's a repetitive function, it's a repetitive process, so we will get the minimum of j theta. The same thing that we did in logistic regression, linear regression previously. The same thing we will do in logistic regression. So kindly have a look at this. So I will not go beyond this. I will just go for the next example. Okay. Hello, no problem. Darshan is saying yes, sir, got it. Okay, okay, Darshan, yes, you are getting it, but I just need to just confirm to other friends also. Hope so you are not facing any problem.
Yes, sir, no problem, sir.
No problem. No? Okay, Rohit. So this is basically, here we have actually done our task. Here we have done our task, and now we will go for our basically the coding section. Okay, we will go for the coding section. Let's start. Okay, let's start. And somebody told me that, sir, I think Aniket Mishra told that, sir, how to find out the accuracy of a model, right? Accuracy of a model. So I will create one new file. JS class 3. Oh, no, it's not class 3. I think it's JS class 4. Or how much? 4. It's already 5. JS class 5. Okay, JS class 5. Okay, I have one data set. Wait, I have one data set. I will utilize that data set. Wait, let me see. I have one data set. Yeah, this data set I have, this binary. This is actually the data set, you know, for the candidates who got admission. Okay, this is actually the data set for the candidates, okay, who actually means whether they got admitted or not. Getting the point? Means if okay, admitted, then the value representing is 1. Okay, admit, then value representing is 1, and if the rejected, then the value represented is actually, it is represented by the value 0. Means this is actually the GMAT score. Okay, no, not GMAT score, GRE score. Okay, this is actually the GRE score. Okay, and the GPA, and is basically the GPA, and their rank they have scored in the exam. Getting the point? The rank they have scored basically. This is basically the thing. Okay, so here the output is in 0 and 1 format, na? It is in 0 and 1 format. Chalo. Let's start with this. What is the name of this data set, man? It's binary, na? Binary. Wait, binary. So I will start from this particular thing. I will utilize this data set.
Sir,
Okay,
here what we are predicting basically in this data set.
Here we will predict that whether the candidate will get the admission or not. Here we will predict basically whether the candidate will get admitted or not. On the input we will take GRE, input we will take GPA, input we will take rank, and we will see whether the person got admission or not, or the person got rejected.
Okay.
Okay, this is actually the thing. So this admit is actually given in the first starting. It is basically always given in the last, but it might be given in the first, so no problem with that. Okay, so let's do one thing. I will start from here. So first of all, I just need to do what? I just need to import the packages basically, you know. I just need to import the packages. Okay, I just need to import the packages. So what are actually the packages that we need to import? Okay, I'm telling you. Import SSNS. Okay, now the last thing, what we have to import from sklearn.linear_model, import logistic regression. Import logistic regression. Okay, this Seaborn I have imported. Seaborn is also for 2D graph plotting. Okay, for 2D graph plotting I have taken Seaborn. Okay, and one is actually Aniket Mishra. Just try to pay attention that, sir, you told how to find the accuracy. We will find the accuracy using this particular model, metrics. From sklearn, import metrics. Let's run this cell. Basically, let's run this cell, and we will actually, yeah, it's done. Now I will read the data set. Suppose I take a variable data. Okay, if I take a variable here data and data dot head, if I run this, see I'm getting this particular. Hope so till here there is no problem. Right? No problem. Now, how many datas are there? I can see that around 399 means 400 data is there. Okay, so is null dot sum anything, any null value? No null values, no null values, no null values. Data dot describe. Okay. So description of the data set. This is actually the description of the data set. Very good. And I will just find out the info of the data set. Info of the data set. Info. Int 64, and one GPA column is actually float 64. Right. Means 3 column integer and 1 column float. Okay. 3 column integer and 1 column float. Okay. Very good. 3 column integer and 1 column float. No problem. Okay. Now I will use a Seaborn. I have written now starting Seaborn as SNS. Okay, Seaborn as SNS. Just have a look. I will use this Seaborn. Today I will show you some graph plotting using Seaborn. Okay, it is also a 2D graph plotting library. SNS
So it is like a matplotlib only, no?
Yes, it's like matplotlib only. It's like matplotlib only. Okay, Seaborn is also like matplotlib. See, I'm showing you. Okay, count plot x equal to, I will plot this rank. Okay, I will plot this rank I will plot. Okay, so rank count plot means it was actually count rank, and this is actually the attribute, and inside this attribute I will pass this data here also I've written data. Oh, so same no problem. And if I run this, I will get output something like this. See, so one rank is scored by 60 people around, 2 rank is actually scored by more than 40 people, rank 3 is scored by around 120 people, and rank 4 is actually scored by 60 people. See, or near about 70 people. Got it? It is very interesting.
Got it.
No problem, no? Okay, let's move ahead. Okay, no problem. Now I will do the same thing. I will do for what to say. I will do the same thing. I for. I will copy this. I will paste it over here, and here. Suppose I will see how many got admission and how many not get admission. So admit. If I run this, oh, near about more than 250 people didn't get admission, and near about 110, 120 people got admission. Okay, getting the point. Clear to everyone? Are you understanding? No problem, na? Okay, very easy, right? Now I will find out features and targets. So see, I just took this from the code itself. See, features. What is actually features? Here features means all the rows and column starting from 1th column. Why 1th column? Because see, 0th column is actually our target. See, 0th column is actually our target, and from 1th column till the end we have all our features, right? We have all our features. So here I have taken from 1th column till the end all the features, and 0 colon 1 means only the 0th column. The 0th column, that means the first column, is our target. So if I try to print here AX, X dot head, I will get what? I will get all the features, and if I write here Y, I will get the target. See, I've got the target. So X is the feature, Y is the target. So divided in features and target format. Okay, just have a look. If this is basically done, now I will see the shape of the data basically. Okay, data dot, oh, 400 rows and 4 columns are there. 400 rows and 4 columns. That means 1 target and 3 features. Okay, so 400 rows, 4 columns. Right? Okay. Now that's it. Now, without wasting time, if I take this particular code from our previous code, then what is the issue? No problem. X train comma X test, Y train comma Y test equal to train comma test comma split X comma Y test underscore size equal to 0.30 random state equal to 40. Means I have divided the data set into 30 and 30 and 70 format. 30% for training, sorry, testing, and 70% for testing, training. Okay, if I run this, what happened? Oh. Chalo, that's it. Till here, no issue. Please confirm once, then I will proceed.
No, sir.
So data set has been divided into 70 and 30 format. So we have 400 records. 400. What is 70% of 400? 7 to 228 means 280 will go inside the training and 120 will go inside testing. Right? This is the funda. So let's see. Let's see. 280 is going or not? What? Achha, spelling mistake. See, 280 is going inside training. Okay, and let's see it. 120 is going inside testing or not? Yes, 120 is going inside testing. Very good. Very good. Now we need to create our model, fit the model, okay, and just go for the prediction. Create our model, fit the model, and go for the prediction. That's it. Test and give prediction. That's it. See, our model is excellent. See, perfect. See, this is not error, huh? This is not error. It's warning. It's warning. Okay, it's warning. Getting the point? It's warning. It is not an error. It is not an error. It is a warning basically. Okay, it is a warning. If you want to suppress this warning, then also you can go for. Shall I show how to suppress warnings? See, if you are getting these types of error, na, see, warning suppressed. This is how you can suppress the warning. Okay, these are actually future warnings. Means in future Python may change these types of packages and all these things, so it is giving warning. So you may suppress these warnings. Okay, so my model is built. My prediction is also done. So the prediction is basically inside YPred. Inside YPred. The prediction is basically inside YPred. Now just have a look, Aniket Misra, just have a look. You said me, sir, how we will get the accuracy? So here we are finding the accuracy. Accuracy, I remember I just imported one model. The name of the model is actually metrics. Metrics. So metrics.accuracy underscore score is the method inside which the first parameter is actually the actual value, that is the Y test, and the second parameter is actually the predicted value. The predicted value, which is inside YPred. So if I run this cell, If I run this cell, I'm going to get an accuracy of around 72%. So my model is getting 72% accuracy. It is giving. Okay, so it is not giving a very much high accuracy, right? It is giving 72% accuracy. Right? Let's do one thing. Let's feed some more data inside the training. Okay, let it divide into 80 and 20. So run this. Okay, and let's see whether it is increasing or not. No, it's decreasing. So it's decreased. Okay, so decreased. So let it be 30% itself. Accuracy decreased. 72. If I change this random state, let's see, 75%. 75%. So 42 is not required. Here random state is 1. So let it be. Okay. 75%. So here the model accuracy around 75. 75 means at least around 76%. See, 75.83 means around 76% basically. Okay, 76%. So this is actually the model accuracy. Aniket Mishra, any doubts? How
Sir,
to find out the
if we
model
want to
accuracy?
check the train dataset accuracy, then what to do?
You have to find the train data accuracy, na? Okay, so here.
Yes, sir.
So see, here we are finding out the train data accuracy. Here, what we are going? Here we are passing the test data, right? Here we are passing the test data. So similarly, you are passing the test data. You have to pass the train data. That I showed in the previous example. Remember? Previous example you were present. I gave one prediction with the training and one prediction with the testing when I was showing linear regression using multiple variable. Getting the point?
Yes, sir.
Sir,
Yes.
I have one doubt, sir. Sir, suppose linear regression and sir, suppose regression problem, we have to suppose calculate the RMSE value, and for classification we have to find the accuracy only.
Yes. Yes.
Sir, if we feed the model with some other algorithm like sir
Like
random tree forest or
random
XGBoost,
forest. Yes,
then
random forest. Yeah, random forest is also a classification algorithm. Okay, so if this model is giving a 75% accuracy for logistic regression, okay, always machine learning data scientists or experts tell us that if you are getting a 75% accuracy on logistic regression, then again you have to build some other model. Okay, like GIS class 1. Wait, class 1.ipynb. Arvind Kumar Mishra, what should be the maximum possible accuracy for our model? See, the maximum possibility is actually what? We know 100%. 100%. Okay, but it is not possible to receive 100% accuracy. Okay, it's not possible. So here I am showing you, this was not actually, again we will go to class 3. I think here we
sir,
will
XGBoost is also a classification.
extreme gradient boosting. Yes.
Yes, sir.
See, yes. See, here, this is basically the thing, right? If I copy this code particularly, if I take this code, this was actually where we built k nearest neighbor in Iris Cloud dataset. K nearest neighbor, remember?
Yes, sir. Yes, sir.
Okay. Now, according to Rohit, if I just take this over here, and here I have passed this particular thing, if I run this xtrain, here xtrain, I think it is in small. So here xtrain will also be in small. Okay, and xtest is also in small now, so here xtest will also be small. Okay, so if I run this, very good. Okay, scores. If I run this, so see, this is actually the accuracy given by, this is the accuracy. See, this is the accuracy which is actually given by our k nearest neighbor. See, k nearest neighbor. 58% when k value is 1, 70% when k value is 2, 64% when k value is 3, 70% when k value is 4, 73%, something like this. See, this is actually the accuracy given by k nearest neighbor. So here, is logistic regression performing better than k nearest neighbor or not?
Sir, logistic is giving me the better.
Logistic is giving the better result because k nearest neighbor accuracy highest is 73%, not more than that. But logistic regression is giving around 76%. So here we did two model comparison. One is the logistic regression and the other one is the k nearest neighbor. Similarly, if you want, when I will show you random forest and decision tree, you can go for random forest and decision tree also on this particular model, right? But this model is not going to give you highest accuracy. You know why? You know why? Okay, because did you see there is a class imbalance in the data set? Can you see there is a class imbalance in the data set? Class imbalance in the data set. Just have a look. The person who got admission is near about 100 and 110. And the person who doesn't get admission is more than around 250, means near to around 280 to 90. Okay, which is 2 to 3 times much more than the person who got admission, right? Yes, so this is basically called class imbalance. Okay, the frequency of class 0 is much more higher than the frequency of class 1. Okay, this is actually called class imbalance. So in these types of problem, either we have to balance the class, means we have to consider more data set. Okay, we have to consider more data set where we get a balanced class. Okay, otherwise we have to work with this much accuracy itself. We have to increase the quality of the data set. That's it. We have to increase the quality of the data set to overcome that class imbalance problem. Getting the point?
Yes, sir.
Okay. Yeah, Arvind Kumar Misra.
Sir, I have one question.
Yes, sir.
Sir, like as you have told, it is a class imbalance.
Yes.
So, sir, whether is there any way such that we split our data set in such a way that means the more negative means in the training part means equal parts of means 0 and 1 goes. Is there a way to we can divide using our own code, like we write our own code and means not the inbuilt functions, using our own code? Is there a way?
See, if we go for deal with class imbalance, okay, there is some problem process by which we can actually overcome these problems. Okay, suppose class imbalanced. When we try to perform, or just see how I did, before it was giving around 72% accuracy, I changed this test size and I changed this random state. Got it? This is the first thing. This is the first thing, right? This is the first thing that I did. What I did basically, imbalance is basically common, we know, and this is basically going to affect the accuracy paradox. We know this, right? So first thing that we need to do, that we can collect more data. We can collect more data. If this is not possible, the second is that we have to change our performance metrics. We have to change our performance metrics. Okay, here two things I have changed. Okay, from which our accuracy increased from 72 to around 76%. Got it?
Yes, sir.
Got it? Okay, right. Now we can basically go for resampling our data set. Okay, resampling our data set. But basically we don't go for resampling our data set right now in this case, because I am telling you, resampling basically means we can change the data set that we use to build our predictive model that have more balanced data. The same thing is basically arising. We are actually changing our data set so that we get we use a data set which has more balanced data inside there to get a better predictive model, right? So this change is actually called sampling the data set. So sampling or resampling the data set, basically there are two types, or there are two things. One, we can add copies of instances under oversampling. We can add copies of our data set, or we can delete the instances from the over-represented class. Means the class which is over-representing is basically the 0 class. So we can remove some further instances of this 0 class. This is actually called resampling. Getting the point?
Okay, sir.
Okay. Now the next part is try different algorithms. So I here tried two algorithms. One is the k nearest neighbor, and the next one is actually what? Next one is what? Logistic regression. This is our first priority. Okay. And the third one is basically we can go for, when I was teaching you logistic regression, we came to know that we can try for penalizing model. Penalizing model. So what is penalized classification? Okay, penalized classification actually imposes an additional cost on the model. Okay, it implies or it uses some additional cost on the model. Getting the point? So either we can penalize the model basically. Getting the point? Hello, Darshan, is it clear?
Yes, sir. Here to sir, we have not calculated the cost like gradient descent.
No,
We have not calculated.
not calculated. Not calculated.
So if we calculate, then it is possible that our accuracy will increase.
Yes. I said na, this is try penalizing the models.
Yes, sir.
Penalizing the model. Okay, so we will apply some optimization algorithm. Okay, in order to optimize our model. Right? That's what we call penalizing, na? Darshan, getting the point? Okay, any doubt till here? Any problem till here? Hello, any problem?
No, sir.
Okay, now again I will go for the prediction. Now I will go for the prediction. See. So we have our classifier inside CLF. We have our classifier inside CLF, and with the CLF I am giving one prediction. See, it's giving me array 1. What is array 1? Array 1 means that person is going to get admission, right? That person is going to get admission, because when we just what is our prediction? Here the prediction is y_parade. If I run this, it will give me the output or predicted value in 0 and 1 format, right? So now from the data set, if this is the data set, I will take something like this 804 and 1. If I take this 804 and 1, the person will he got admission, right? He got admission. So 800, 4, 1. Let's see. So 800, 4, 1. If I run this, it is giving me 1. See, it is giving me 1 prediction. Means the person is going to get admission. Now I will take this account. 520, 2.93 and 4. 520, 2.93 and 4. That means the person is not going to get admission. 0. 520, 2.93 and 4. Ruko. 520, 2.93 and 4. This output should be 0. Let me run. So it is giving me 0. See. So here it is giving me an output with an accuracy of around 76%. It is giving me output with an accuracy of 76%. Getting the point, everybody? Okay, is this part clear? Hello? Hello? Hello. Yeah, Darshan, is that clear? What about the, yeah, Oniket is also saying yes, sir, clear. Okay, what about the rest? Okay. Perfect. Okay, so here we learned about a lot of things, lot of new things basically. Okay. Right, so this is basically the concept about logistic regression, right? Logistic regression, which basically gives a sigmoid. Okay, which basically gives a sigmoid. Now, okay, so now So we went for a very what to say, nice prediction basically. Okay. Fine. Now, let's do one thing. Let's do one thing. How to basically define this logistic regression from basically scratch. Okay, how to define this logistic regression from scratch. Okay, now I'm defining some more values, suppose. So see, here it is done, and here I will just do one thing. Here I will just create one heading tag. Okay, here I will create one heading tag, and here write logistic regression scratch. Okay, the same thing I'm implementing. Don't worry. So on the x-axis, I'm going to do what? I'm just in the x-axis. I'm just going to take the GRE, GP, and the rank. Okay. On the x-axis, I'm going to take the GRE, GP, and the rank. Okay. On GRE, GP, and the rank. And the y-axis, I'm going to take what? I'm going to take secret. Just a second. I've just taken this GRE. Okay. And I will take the GPA, and the rank. And on the y-axis, I think our target was admit, right? So if I just pass here x, okay, data. Okay, so on x we have this, and on the y we have the, okay, perfect, chalo, done. On the x-axis I have taken the features, on the y-axis taken the target. Okay, so this is basically the thing. Now I have to do what? I have to define the sigmoid function. Remember sigmoid function? What was sigmoid? 1 upon 1 plus exponent of the input. Yes or no? 1 upon, yeah. So if you need to display basically the sigmoid, if you need to basically define the sigmoid, so you have to write the function, because for logistic regression there is no such, actually, there is no such function in Python. Okay, so you have to develop this from the very scratch. Okay, just I'm showing you, just have a look over here. Okay, try to have a attention. So if you need to penalize the model, or if you need to, if sigmoid, with the help of def, we basically define a user defined function. Input. Okay, so output is basically going to be what? 1 upon 1, I think it should be within bracket, 1 upon 1 plus, okay, we have to import numpy, right? Import numpy as np. So np dot exponent, exp, okay, exponent of what? Of input, right? Of input, and this is going to return the output. It's going to return the output. Okay, perfect. Okay, now we will initialize the weight. Okay, we will initialize the weight and the bias. Bias means the error. Okay, init parameter, suppose this is an empty. Okay, this is empty, and if I just represent this weight, weight equal to np dot, I'll convert it into zeros. Hope so I have showed you all these things in Python. Okay, and this thing equal to 0. right? So here I have defined the weight and bias. Okay, here I have defined weight and bias, right? Now weights and bias are basically, these are the what to say, learning parameters in machine learning models. Okay, these are the learning parameters in machine learning models. So weight bias is basically, it's defined like some inputs which are actually provided to the, some input which are basically provided to the model, and which each input one weight is basically associated, one weight is actually associated basically. And bias is actually used to, or it is commonly associated with a phenomena which is against the algorithm, which is against, or the result of an algorithm, which is, means it is actually considered as, you can say, it's an error, it's an error that actually occurs in machine learning model itself due to some incorrect assumptions, basically. Getting the point? Okay, means if a bias, if a model which has a low bias, that means it is actually closely matching the training data, the model is highly perfect. And if a model has a high bias, then it is actually far away from the ground truth. Got the point? So here is what I just showed you, basically how to go for this weight and bias. Now we know basically the train function. Okay, so the training, basically all these things, it's perfect. Now if you want to penalize this, if you want to penalize this model, again we have to do what? Def train. I am showing you, or I am creating one training function. So here I'm going to pass x comma y, right? Learning rate, iterations, learning rate and iterations. So parameters output equal to optimize, okay, optimize learning rate, iterations, right? Got it? And it's going to return this particular value. So this is basically my training function. This is my training functions. Now let's train the model. Let's train the model. I will call this function train. I will pass x, I will pass y. Okay, I will pass this learning rate, okay, equal to 0.02, something like this. Okay, and I will pass this iterations. I will pass this iterations equal to, suppose we don't have a very high data set, suppose 500 iterations. Optimize is not defined additionally. Okay, so here we have to actually do what? We have to define the optimize basically. Okay, we have to devise the optimize basically, right? Optimizing, okay, no problem. Optimize. Wait. by import optimize. Module object is not callable. So we are getting a type error over here, right? Just a second, don't worry. We have written the sigmoid function. Okay. We need to write one more function, you know. Wait. Sigmoid. I think there is some problem. Optimize x comma y comma iterations parameters. Okay, so size equal to x dot shape 0 and weight equal to parameters weight. Okay, and here simply for bias right, bias. Now we have to go for a for loop, you know. You have to go for a for loop, because if you don't just don't go for the for loop. Okay, so this part was actually done, this part was actually done, so it will be stay, it will be as it is. Okay, and this one is also going to be something like this. It will be as it is. Now in this for loop, where is our training function? Okay, so this is actually our training function. So we need to define this optimize. We'll need to define this optimize. Okay, now for this we require a for loop. Okay, let's move ahead. For I in range, I'm giving you basically the code how to actually, I will explain each and everything. Weight plus bias, loss minus 1, size multiplied by np dot sum, y multiplied by np dot log. This was the formula of sigma. plus 1 minus 1. That's it. That's it. Perfect. Done. Okay. That's it. 1 minus y. So this is perfect. Now since this is done, now the next task is that we have to basically multiply this with, okay, we have to multiply this np dot log 1 minus sigma, np dot log 1 minus sigma. Okay, so this is the formula that we have implemented. Perfect. Now after this we need it will give name error because iterations is basically not defined additionally. Okay, let it give, no problem. Now here we have to basically define our iterations and all these things. That means first of all we have to calculate the weight, and then we have to calculate the bias. Okay, we have to calculate the bias, multiplying it with the learning rate, okay, so here we have actually initializing the parameters. So initializing the parameters. Okay, so for the first half this will be till here only. Got it? We have already completed it, but I'm showing you how we can actually extra modify this particular experiment or this particular model. You have to write down the code from the scratch. Okay, so first I have taken x and y, then I have prepared the sigmoid function, then I have prepared the optimize function, and then I am actually going for a for loop. Right after this, our data is already reshaped and the method for training is already created, so much is not left. Okay, then we will go for this particular experiment. So till here it will be till here only. Now I will take the attendance. Wait, we'll continue this. So whatever we are doing till now, I hope so there is no doubt. Hello.
No, sir.
Hello.
Yes,
No
sir.
doubt, no? Okay. Yeah. So it is very simple. Okay. If your mathematics is clear, statistics is clear, no issue. Okay. Let's move. Okay. First half. Okay. Anusha Bera. Hello. Anusha Bera. Okay. Zayed Siddiqui. Shrestha Poddar.
Present, sir.
Okay. Srishti Bose.
Present, sir.
Very good. Aditya Narayan Das. Okay.
Hello,
Bhavato
sir.
Sarkar. Aditya Narayan Das
Hello,
is present.
sir.
Yes, sir. Bhavato Sarkar.
Acha, Bhavato Sarkar.
Hello, sir.
Yes, who is this?
Sir Srishti, I'm present, sir.
Srishti, you are present. Yes, Srishti, you are present. No problem.
Yes.
Yeah. Bhavato Sarkar is present. Yeah, Bhavato Sarkar is also
Sir,
present. Yeah, Budha Ditto.
Present, sir.
Present. ঠিক আছে, দেবজ্যোতি wait, দেবজ্যোতি সাহা. Okay, Devapam Das. Okay, Dipayan Khatua is absent. Aditya, you are present. Aditya, don't worry. Okay, Deepi Ranjan is present. Iman Kalyan not present. Kaushik Devnath.
Present, sir.
Present. Okay, Pratik Seth. Right. Pratiksha Ghosh. Okay, Pratyay. Acha, Pratiksha is present. Acha, Pratyay is present. Pratyay present. Prayas Basu. Prayasu ache.
Yes, sir.
Okay. Rishin Haldar. Rohish Ray, Rishan Haldar present.
Yes,
Rohish
sir.
Ray, yes,
Yes,
Rohish Ray
sir.
present.
Present.
Okay, Rupam Sarkar present. ঠিক আছে, আচ্ছা সঞ্চিতা দত্ত,
Yes, sir.
ওকে, সপ্তর্ষি সেন, সায়ন চক্রবর্তী,
Present, sir.
ওকে, শেফালিকা প্রেজেন্ট, ওকে, সৌমিক কুন্ডু নেই, শুভম চৌধুরী,
Present, sir.
ওকে 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 ওকে, সুমন ঠাকুর,
Present, sir.
ওকে, सूर्यदीप रॉय, अच्छा, आकाश इज प्रेजेंट, ओके, आनंद मोहन झा,
Present, sir.
ओके, आकाश इज प्रेजेंट, आनंद मोहन झा इज प्रेजेंट, ओके, अंगना दास,
Sir, Angana Das present.
ओके, अनिकेत मिश्रा इज प्रेजेंट, ओरिंदम सिंह इज प्रेजेंट,
Yes, sir.
ओके, ओरित्र घोष
Yes, sir.
प्रेजेंट, वेरी गुड, अरविंद कुमार मिश्रा इज प्रेजेंट, आयुष मिलन আছে, आयुष मिलन,
Yes, sir.
okay, Bilal Ahmad, he said that he is present, okay, Darshan is
Present, sir.
present,
Present, sir.
okay, present. Yes, Gargi Devnath, Gargi Devnath আছে, জিৎ সাহা, ওকে, কৌশল পণ্ডিত, কিংসুক বিশ্বাস, মেঘা পল আছে,
হ্যাঁ, present, sir.
প্রেজেন্ট, মোহিত সাহাল তো নেই, আচ্ছা, নিখিল কুমার আছে,
Yes, sir.
निखिल कुमार है, हाँ, पंकज घोष
Yes,
प्रेजेंट
sir.
है, ओके, पंकज घोष प्रेजेंट, प्रभात कुमार,
Hello, sir. Devji, sir. Hello.
यस प्रेजेंट,
Hello, sir. Pratik sir, present.
given, Pratik, don't worry, given,
Okay.
okay, don't worry, yeah, so yeah, next is Rakesh Roshan,
Sir, Prabhat Kumar present or no?
प्रेजेंट है प्रभात कुमार,
হ্যালো স্যার,
হ্যাঁ বলো,
দেবপম দাস দেওয়া হয়েছে?
দেখো, দেবপম দাস তো আমি যখন বললাম তখন তো কিছু বললে না তুমি,
স্যার অ্যাকচুয়ালি মাইক প্রবলেম হচ্ছিল, আমি মানে সঙ্গে সঙ্গে অন করতে পারছিলাম নেটওয়ার্কের জন্য।
অ্যাবসেন্ট আছে, দাঁড়াও প্রেজেন্ট করি, চলো প্রেজেন্ট হয়ে গেছে, ওকে, দাঁড়াও 1 সেকেন্ড দাঁড়াও, ওকে, রেশমি প্রেজেন্ট,
Yes, sir.
ওকে, রেশমি প্রেজেন্ট আছে, দাঁড়াও,
Sir, present.
রোহিত প্রেজেন্ট আছে, আচ্ছা, রৌনক
Yes,
প্রামাণিক,
sir. Present, sir.
হ্যাঁ, সঞ্জনা রানী আছে, সঞ্জনা রানী, ওকে, সপ্তর্ষি কুন্ডু, সপ্তর্ষি রয়, Shayan Bagh. Shayan Bagh.
Yes, sir. Present, sir. Sayanbag.
Shamini Ghosh.
Present, sir. Sayani Ghosh.
Shreyas
Sir,
Kumar
Sayanbag
Ghosh.
present.
Okay, okay. Shayantan Ghosh नहीं. Shreyas Kumar Barnwal.
Present, sir.
Very good. Simran Kumari. Simran
Present, sir.
Kumari. Okay,
Present,
very good.
present.
Okay, Sneha Goswami. Present.
Yes, sir. Present. Present, sir. Sneha Goswami.
ঠিক আছে ঠিক আছে ঠিক আছে আমি দিয়ে দিয়েছি ঠিক আছে আচ্ছা সোহম ভট্টাচার্য সৌতি সামন্ত সৌতি সামন্ত সৌতি সামন্ত অ্যাবসেন্ট আছে আচ্ছা সৌরভ বাগ এ তো অ্যাবসেন্ট আছে শুভাশিস পল সুধজিৎ দে সুমিত কুমার सूरज माइती
Hello, sir.
Yes, sir.
Subhasis
Suraj
Paul
Maiti.
present.
हु कौन कौन
Hello,
सुभाषिस पॉल प्रेजेंट वेट
Yes, sir.
रुको 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 हड़बड़ी मत सुभाषिस पॉल प्रेजेंट अच्छा सूरज माइती प्रेजेंट है सूरज माइती
Yes, sir. Suraj Maiti
Okay.
present.
ओके वर्धन सासुत्तो तो एब्सेंट रिद्धिमान प्रेजेंट
सर वरदान शाश्वत प्रेजेंट
कौन
सर वरदान शाश्वत
वरदान इतना दिन क्लास में नहीं आया भाई ओहो चलो प्रेजेंट कर दिए चलो
मैंने
चलो 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 कोई बात नहीं चलो क्लास अब रेगुलरली अटेंड करो
I am also present.
Who is this Sanjana Rani wait
Hello.
wait
Yes, sir.
wait Sanjana Rani wait हाँ चलिए प्रेजेंट हो गया संजना रानी चलिए ठीक है ত্রিদীপ্ত আছে আজকে ও আরে ত্রিদীপ্ত কতগুলো ক্লাস মিস করে দিলে তুমি ত্রিদীপ্ত প্রেজেন্ট চলো অনেক মিস হয়ে গেল তো ও
স্যার ক্লাস মিস হয়নি অ্যাকচুয়ালি স্যার নেটওয়ার্ক প্রবলেমের জন্য অ্যাটেন্ডেন্সটা হয়নি
আচ্ছা দাঁড়াও
মাঝখানে ডিসকানেক্ট হয়ে গেছে অনেকগুলো ক্লাসে
গার্গী দেবনাথ দাঁড়াও গার্গী দেবনাথ ওয়েট গার্গী দেবনাথ
হ্যালো
एक्चुअली चलो गार्गी देवनाथ হয়ে গেছে यस नेक्स्ट बोलिए
স্যার সপ্তশ্রী সেন প্রেজেন্ট স্যার
সপ্তশ্রী সেন দাঁড়াও সপ্তশ্রী সেন দাঁড়াও ভাই একটু দাঁড়াও ওয়েট করো
হ্যাঁ শিওর
সপ্তশ্রী সেন Saptosri Sen present okay next anybody left acha Debojyoti Saha তুমি তো অলরেডি প্রেজেন্ট আছো you are already present anybody else left or shall I submit कोई बाकी है और जिसका अटेंडेंस नहीं हुआ या फिर मैंने नहीं बुलाया नाम कोई है चलो आई एम सबमिटिंग द अटेंडेंस ओके चलो पक्का परफेक्ट डन चलो okay so that's it so this is basically our optimization okay this is actually our optimization function and now Okay, so till here only right now we have defined our model. Okay, so X contains all the features, Y contains all the target, and here we have the sigmoid function, and after the sigmoid function we have optimized. This is the optimization function basically. See, Rohit, are you present na? Rohit and Darshan, both are
Yes,
present.
sir.
हाँ, दोनों present
Yes,
है ना?
sir.
तो
Present, sir. Yes,
yes,
sir.
so both of you, yeah, आप लोगों का दोनों में देखिएगा, आप लोगों ने मतलब एक एक सवाल का आंसर दिया. You both you gave one answer to my question. That sir, if we consider the bias and the weight, then definitely we are going to get the actual output, right? Okay, so see, the same thing I have implemented here also. Sigma equal to sigmoid of dot of input which has got some weight plus the bias. Okay, so that is equal to the sigma, and here is the loss function. Okay, here is the loss function which has been actually separated from the sigma, and this is actually the error, and we have multiplied it with the learning rate, because in each step it is going to, since we have got a lot of iteration, so in each step we are going to get a new weight and a new bias. Okay, and we have stored it inside a variable and we have returned that variable, right? Then we have reshaped that value, and after reshaping we have used the train, right? So this is actually the scratch. We are actually building it from scratch, right? We are trying to build this thing from scratch. Okay, sigmoid is already built, okay, optimization function is already built. We have initialized the parameters also. We have initialized the bias to 0, and weight we have taken as the input, and then we have defined the method for training also, right? And I had already written one training function. Okay, I already wrote one function for training, right? And after that I took the learning rate as 0.02 na, this learning rate. So if we run this, so let's see, our training is getting, yeah, so our model is trained basically over here. See, our model is trained. Okay, our model is trained. Now since our model is trained, that's it. The next part is what we have to go for our, prediction. Basically we have to go for our prediction. Getting the point? We have to go for our prediction. So how to go for the prediction? This I will show in the next session. Okay, I will show it in the next session. Got it? So for now, okay, this is enough for today. Okay, enough for the first half. Okay, go have your lunch, रिफ्रेश होइए, नेक्स्ट हाफ में आइए, उसके बाद बताते हैं कि यहाँ पर प्रेडिक्शन कैसे दिया जाएगा और हम लोग प्रेडिक्शन कैसे करेंगे. ठीक है, चलिए, थैंक यू, टेक केयर ऑफ योरसेल्फ एवरीबॉडी.